Okay, so this is going to be the last video for this topic, for this lesson on Friday. So this is not in the notes, but I was just looking at some AP questions and I thought it would be beneficial for y'all to see how they could ask about this topic using integrals for area in terms of x versus y. So this is kind of just makeshift. I just took a sheet of paper and wrote this down. If you want to do the same and work it out, or if you just want to watch and take notes on your own sheet of paper, whatever you feel is most beneficial to you. So this problem says, let R be the region in the first quadrant bounded above by the graph of y equals 7/3 x plus 1 and bounded below by the graph of y equals 2 to the power of x. For the interval x is between 0 and 3, which of the following definite intervals gives the area of R? And they give you three different options. And so the first thing you should notice is this first integral is in terms of x, and these bottom two are in terms of y. So those boundaries need to match, right? So if this is in terms of x, these boundaries need to be x values. And if this is in terms of y, then these boundaries need to be in terms of y. That might help you later on pick your answer as soon as we get going. So let me actually go and get my notes. So we know that since this one's in terms of x, it should match this. It should be top minus bottom. And these are in terms of y, so it should be right minus left. So if you want to get a sketch, it might help on this problem. It might be a little difficult to sketch at first, but it does give you some stuff that helps. It tells you that this one is the above, the top one, and that this graph is below, it's the bottom. So right off of the bat, you should probably be able to tell that this one, that's in terms of x, it has the right top and the right bottom. And then this is really giving you your boundaries. You want to go from 0 to 3. Now I guess we should make sure, well, it tells you, never mind. I was going to say we should make sure that it doesn't switch, but it tells you this is above, this is below for that whole interval. And so let's go ahead and get a sketch though, but that's looking like it should be good. I think if we get a sketch, it'll help us with the terms of y. So our first one, we know that that's just a linear line with a y-intercept of 1 and a slope of 7/3. So you can be now you should make sure you put the y-intercept right. And now 7/3, it's kind of up to you how you want to do that. If you want to actually, so if we count up 7 from 1, we would be at 8, and then over 3. So I'll just say that's right there, about, and draw a linear line. Linear line, that's kind of repetitive, isn't it? Okay, so now this one, hopefully you think about what type of parent function this is. It has x in the exponent, so it's exponential, right? So we know, hopefully, what an exponential graph looks like. All exponential parent functions, if there's no plus or minus, go through 0, 1, so they also have a y-intercept of 1. And they go along the x-axis, and then they curve up. Now, where should we curve up? You know what? I'm going to actually pause here and see, well, even knowing the intercepts would be hard, huh? To set those equal. But I'm going to kind of cheat and show, because we know that it's from 0 to 3, right? So let's think if we plug in 3. Where should these graphs be at 3? So on the for the red line, if I plug in 3, so I'm looking at this end, because I know at 0 they're both at 1. If I plug in 3 for x, divided by 3 and multiply by 3, that cancels. So that would just be 7 plus 1, which is 8. So we know this ordered pair right here is 3, 8, which we already knew from counting the slope. Now let's plug in 3 to our exponential. 2 to the power of 3 is also 8. So they should intersect right there at 3, 8. So it curves up like that. Okay, so if they give you an interval, a boundary, go ahead and see is that the intersection points for it. Most likely will be. So we're talking about this area in between here from 0 to 3. So if we're going to do vertical, if we're going to use the formula for vertical, we want it in terms of x, so we want it y equals. These are already in terms of y equals, so this one should be easiest to set up. You just go from the left x value of the intersection point to the right x value of the intersection point and do top minus bottom, which it doesn't change, so we can do one integral. So it starts at what x value? Maybe I should do different colors. I'll do this one in purple. And it starts here at 0. And it goes all the way over to 3. Right? When you draw vertical lines. And we do top minus bottom, so top is the red. So that's 7 over 3 x plus 1 minus the green, which is 2 to the power of x dx. So if you notice, that matches this one, so that is a good integral. Okay, now let's think if we do horizontal. Now this one you got to do some rearranging, because, well, we could go ahead and start our integral, but then we're going to have to go to the side and do some math. Also, that is an ugly integral, but besides the point. So when we go horizontal, which I don't know if this blue is gonna, you can tell the difference on the video, but we're using our y-intercepts, right? Or the y value of the intersection points, I should say. And we draw horizontal lines. So when you do that, what's the y value that you start? The lowest y value that you start, that they intersect at, was 1. So that is your A. And the highest y value for that intersection point was 8. So that is your B. Notice for your two intersection points, the x value is what you use for this one, the y values are what you use for this one. And now we got to do right minus left, right? So we know the right is our green function and the left is our red function, and that doesn't switch, so we can set up one integral. But it has to be in terms of y. So we got to solve these to be x equals. But this one should be pretty easy to do. This one we got to kind of talk about. So let's go ahead and do the red one first. So I'm going to go over to the side down here, and I'm going to rewrite my original y equals 7/3 x plus 1 and solve that to get x alone. So I would do minus 1 first, and you're left with 7/3 x. So then to do this, I would multiply by the reciprocal. So then you got to multiply this whole side by the reciprocal. And if you kind of look, that's how they left it. So I wouldn't go try to distribute that anymore. You're not necessarily wrong if you do, but it's not going to match what they have. So I'm going to leave it like that. 3/7 times y minus 1 would equal x. So I got the first one in terms of y. I got it x equals. Now the second one is y equals 2 to the power of x. If you do around the world, you are not necessarily wrong, but again, it's not going to match how they did it. Now you can kind of look at this and guess what it might be, but let's see why that's it. So what they did is, I don't know if you remember from our chapter 6 when we were doing differential equations, we did this a lot, is if we're trying to solve for x and it's in the exponent, so we need to take the log of each side, and instead of doing around the world, because that would be base 2, as long as you do something to one side, you can do it to the other side. So if we can take the natural log of both sides, which that doesn't match, right? Natural log, it's base e, and that's base 2, so that nothing cancels right away. But we can rewrite it as natural log of y equals natural log of 2 to the x. And we have something, a log rule, that if you have an exponent on the inside, what can you do? You can pull it out, the exponent out, and it becomes a coefficient for the log, right? So we can take this to the power of x and bring it to the front of the log as just a normal coefficient. So that becomes natural log of y equals x times natural log of just 2. So now x is no longer inside a log, and it's no longer an exponent, so we could get it alone, because this is x times natural log of 2. So we can divide by natural log of 2 on each side. And now we have x alone. X equals natural log of y over natural log of 2. So that is how they got the exponential function in terms of y, got x alone. So this is our green function. I switched colors, now it looks blue. This is our green function, And this is our red function when we're doing it horizontally. So we already have our boundaries. Let's go back. We said it's going to go from 1 to 8, and now we're drawing horizontal lines right to left, so the right function is the green, which is, oh well, I'll just stick with it, natural log of y over natural log of 2, and then subtract the left function, which is the red, which is, in terms of y, it would be 3/7 times y minus 1 dy. So if you notice, that should match this third one. What was wrong with the second one? The inside was the same. It was still right minus left, but they had the x values as your boundaries, right? When we do horizontal lines, it didn't go from 0 to 3. You draw them horizontally starting at the bottom and shade up. So it's the y values from 1 to 8. This is staying inconsistent. The boundaries are x values, but the integrals in terms of y. So that is wrong. So we would, if it was multiple choice, we would pick the answer that said 1 and 3. So there, I'm going to put a very similar question. It's almost even a little easier, but very similar process on your assignment. So hopefully this helps you do that one. I wanted you to see this because I know that solving for x and the exponent, we haven't done something exactly like that before. So good luck as you're working on your assignment. Please send me questions if you have any. It is going to be a mix. So there's going to be some in terms of y and some in terms of x, because that's the goal, is that you can differentiate between when you should do which one. So again, technically you could do either on either one, but sometimes it's going to be way easier if you pick the quote-unquote right one. So have fun. Have a great weekend. I don't know if your days are merging together like mine are, but do something fun, keep yourself active, and keep doing calculus. Let me know if you need anything.